Alright, let's look at the homework 17, problem number 1, part A. Alright, so we're looking for the scalar potential phi such that gradient of phi is equal to negative of the conservative field F. Right? So we know that the partial, so gradient of phi is going to be partial derivative of phi with respect to x, comma, partial derivative of phi with respect to y, right? And we know that this has to be equal to negative of this conservative field. So it's going to be negative y sine of 2x and comma and sine squared of x. Alright, so let's match these guys up. So we have, oh actually I forgot the negative sign, didn't I? So here. Alright, so we're gonna match partial derivative of phi with respect to x with this guy. Right? So by taking the antiderivative, we can get phi, right? So by taking the antiderivative of this guy, negative y sine of 2x with respect to x, right, we can get, right, negative y is a constant, so we'll put that there, right. Antiderivative of sine of 2x is going to be negative, so I'm going to turn it into positive cosine of 2x over 2, right? So we have that, and then you might have some plus some constant, but actually it could be a function of y, so it could be a function of y, so I'm going to call it say some function f of y, right? So that much we can get, and then by matching partial derivative phi with respect to y with negative sine squared of x, right, we can do, so we take the partial derivative phi with respect to y, right, so this will get us, right, so partial derivative of this with respect to y would be cosine 2x over 2, right, and then plus y prime of y, right. Then if you rewrite it, right, so since we have to match that with negative sine squared, and remember that cosine is going to be let's see, the same thing as 1 minus 2 sine squared of x, right? So we have that, and let's see, then you have a over 2, right, plus y prime, f prime of y, right? Then you can see that this is going to be equal to, right, so this is 1/2, and you would have 2's cancel out, so it's a negative sine squared of x plus f prime of y, right, and this is equal to, remember that it's a negative sine squared of x, all right. So which means that here we can cancel negative sine squared of x, negative sine squared of x. And so this is going to give us, so this will tell you that f prime of y is going to be, I'm going to put this guy over to the other side. So f prime of y is going to be negative 1/2, right? Which means that f of y is going to be antiderivative of negative 1/2 with respect to y, which is going to be negative 1/2 y, right? And if you want, you can put a plus constant. Alright, so therefore we have a complete formula for phi. Alright, so scalar potential is going to be, alright, so let's see, phi, we know that this is going to be, maybe I should write this as y over 2 cosine of 2x, right? Then you have negative y over 2 and plus some constant c. Alright, and if you want, you can just factor out the y over 2 and you will get cosine of 2x minus 1. Right, then plus some constant c. Right. Alright, so that's that. Alright, so this is the answer. So scalar potential that you're looking for. Alright, that's it. I hope that this was clear.